guys. Let's read through activity 8. Confirm naman dyan. Kita nyo ba?
Yes, ma'am.
Na po.
Okay. Okay, photometric stereo activity 8. So let's read line per line. Introduction. Surfaces are bright or dark due to their albedo or reflectance, another word for reflectance, or the amount of light they are receiving. In this lesson, we discuss the different sources and shadow models and apply them in extracting shape from shadow. So reflectance or albedo at the point P on a surface rho of P is the ratio of the incident light over the reflected light. Okay. Itong photometric stereo is known also as shape from shadow. Yung una natin, yung stereometry, shape from stereo. So, sources and shading models. An object is a light source if light coming from it is internally generated. Therefore, reflecting surfaces such as the moon do not qualify in this definition. However, since they do affect the brightness of other surfaces, they are known as secondary sources. So, point source. Brightness from a point source drops by 1/r². Let B of P be the brightness at a point P, and N hat of P the normal vector at point P. Sorry, kulang ng hat itong drawing na to. S of P is a vector from this point on the surface to the source. Okay? And R of P is the distance from P to the source. So getting that convention, we will discuss different brightness models depending on the source. For example, a light bulb in a room. For a nearby point source, the 1/r² dependence is pronounced or obvious. Okay? The brightness of a surface patch P of P at point P is then a function of the reflectance at point P, the dot product between the surface normal and the vector between that point P and the source over r². So, malinaw ba kung bakit ganito in dot S? Kasi yung, very important yan, have a look here. Yung amount of flux, if you think about that as parang flux na, yung syempre yung flux na tumatama dito is dependent kung gaano ka tapat yung area na to dun sa sa source. And so at if the surface normal is parallel or is at the same direction as the source vector, then maximum yung brightness nitong surface na to. Yun lang ibig sabihin nun. Kaya siya dot product. And of course, the r², 1/r² dependence. Okay? How about if the, malinaw ba yun? The light source is at infinity. At infinity, radial waves traveling from the source will appear as plane waves to the surface. Thus, S of P is constant everywhere and we can replace it by S not vector. And the 1/r² dependence disappears. Nakakita naman kayo ng demo nito. Gawa kayo ng concentric circles from a point source. Farther away, yung concentric circles na yon, yung arc nila magmumukhang parallel lines. Nakita na kayo ng ganon. So wala nang dependence sa 1/r², which is why it disappears, and you can think of all the source vectors as the same, pointing in the same direction. And therefore, the brightness at that point P is just the reflectance times the dot product of the surface normal at that point and the source direction. Now, how about a line source? A line source ay yung mga mahaba. Okay? Like a fluorescent lamp, yung paba. Xenon lamp, xenon scanner, paba yun. Now, for this kind of light source, the dependence on distance drops off as 1 over R. There is a 103 exercise that shows that for a source, for a charge in a line, along a line, yung field niya is dependent on 1 over R and not 1 over R squared. Okay? So example, X-ray view boxes in the yun. So the line source, ito lang, ang mangyayari lang dito, B of P something something over R, 1 over R instead of 1 over R squared. So parang equation 1, pero magiging R na lang tong baba. Now, how about an area source? An area source, parang 2D yung source mo, no? Like X-ray view boxes or the sky on a cloudy day. Ba? The sky on a cloudy day. Kasi parang flat yung source. Hindi yung parang isang point in the skies. Okay? So the amount of the light surface receives is integrated over the area of the source, considering each infinitesimal element of area as a point source. Extended yung light source mo in 2 dimensions. Isa-isa mong gagawin yan. Parang may ganito ka, point per point, isa-sum up mo yung mga ito. Okay? Okay, so ito yung iba't ibang models ng brightness given the appearance or the geometry of the light source. Now, let's go to the photometric stereo technique. Okay? Chat ko lang para nandyan yung equations. So, simplihan muna natin. Let's consider a point source at infinity. Okay? And the source vector is S1. Constant lang to, guys, di ba? Now, assume that intensity I captured by a camera at point XY is directly proportional to brightness of the surface at the point. So, pag kinunan natin ng image yung surface, yung intensity ng pixel at that point is just proportional to the brightness at that point. Tapos merong proportionality constant naman. So, pag pinalit natin yung B na for a light source na at infinity, nasa earlier equation yon. So, that would be rho at point XY times the dot product of the surface normal at XY dotted to S1. And of course, times K. Now, we can rewrite this as a dot product between a vector G and a vector V1, with G defined as the reflectance at that point times the surface normal at that point. So that gives V1, this vector, as the proportionality constant times the source vector. Okay, so that's for one image. We can estimate. Akit ko lang. Yeah, okay. Ayos pa tayo, guys? Carry pa? Huy, react.
Yes, ma'am.
Hindi ko kayo nakikita eh. Ano ba yan? Kung nasa class tayo, nakikita ko mga mata nyo. We can estimate the shape of the surface by capturing multiple images of the surface with the source at different locations. Ito yung technique, guys. Kukunan nyo ng different location, image at different location. The information about the surface will be coded in the shadings obtained from the images. So, let's assume there are n light sources in 3D space. No? So we can define a matrix B11, B12, B13, B21, B22, B23, ellipsis, Bn1, Bn2, Bn3, where each row here is a source, and each column is the X, Y, and Z component of the source. If we take n images of the surface, each using each of these n sources, Then for each point, xy on the surface, we can get, so each image, say the first image I1 is just this, which is a dot product, right? Tandaan, balik tayo doon, di ba? We can write I as a dot product of the surface normal modulated by the reflectance of the surface times the vector of the source times some constant k, right? So yung dot product yan, ano? So, mangyayari, I1 for that light source would be having intensity which is equal to this dot product P11 times G1 plus P12 G2 plus P13 G3 and I2 as well P21 G1. Okay. Or in matrix form, I is equal to the square the n by 3 matrix V multiplied by the 3 by 1 matrix G. But this would be for all points. For in any point x, y, meron kang G1, G2, G3. Pre-preho yan G1, G2, G3 ha. Bakit? Kasi it's a point on the surface. It's the same point on the surface. Tandaan yan ha. So this G looks like it's a 3 by 1 vector multiplied by B, which is an n by 3 vector. Now, since alam natin yung I, ano ba yung I? Yun yung image na kinapture natin, guys. And assume natin na alam natin yung V kasi alam natin yung location ng mga light sources. We can solve for G in the least square sense by Wiener estimation, no? So, get the transpose of P, multiply it by B, and take the inverse of this square matrix, and then multiply it by B transpose, and then multiply it by I. Not the identity matrix, guys. This is I, the image. Okay. To get the normal vector, we simply normalize G by its length. So the normal vector at that point xy is just the G vector. Hello, bakit hindi bold to? Divided by its length. Hindi obvious na bold. So, dapat i-rewrite ko to para mukhang bold. Pakilagyan na lang ng arrows, guys. Pero vector to ha. So to get the shape from normals, note that if the surface elevation is expressed as a function of xy, z equals f of xy, we rewrite this as c, xyz is equal to z minus f of xy equals 0. Get the gradient to get the normal vector. So kunin natin yung gradient nito and you will get minus partial f with respect to x, I hat, minus partial f with respect to y, j, plus k. Kasi ito nga, partial c with respect to z, eh then siyempre magiging 1 yan. That's why k na lang dito. Yan, negative sign dito, negative sign, and dahil negative to. Okay? So once the surface normals nx, ny, and z are estimated using photometric stereo, they are related to the partial derivative of f as follows. Yung partial of f with respect to x is actually equal to the ratio of the x component of the normal vector over the c component of the normal vector, where partial f with respect to y is related to the minus of the y component of the normal vector over the z component. So, the surface elevation z at the point uv is given by fuv, and it is evaluated by a line integral. Okay. And the surface, which is FUV, is the integral of partial f with respect to x dx from 0 to u added to the integral, line integral from u to v partial f with respect to y, dy. Okay. So, again, ang steps nito ay dahil makakasolve tayo ng g doon sa ito, makukuha natin yung surface normals at each point. So, nx, ny, nc for each point makukuha natin. Ngayon, itong equation na to describes sa surface, ano? Itong parts na to, makukuha natin from the computed surface normals. So pag plinag in natin dito yan, to get the function f, we have to do a line integration of this equation. And we get that through this line integral of partial f respect to x. Yan. Okay. Alright? So ano yung gagawin? So ano yung procedure dito? So meron akong in-upload na synthetic image. Ang pangalan ay photos.mat, which contains 4 images. I1, I2, I3, I4, I4. And the image are hemispherical surfaces illuminated by a faraway point source located respectively at these locations. Ito, bali, ito yun na yung unit vector ng kanilang direction nitong light source. Okay? So, load natin yung photos.mat and i-enter natin to as our V1, V2, V3. So, compute natin yung surface normal using equation 10 and 11. So, meron na tayong image, itong I1, so 4 yung image na yun, I1, I2, I3, I4. Yun yung nasa photos.mat. Yung V naman, iyan yung values na nakasulat dito sa baba kanina. So, itong equation 10, gagawin lang natin itong matrix operation na to. Kaya mangyayari, point per point, meron tayong value for G, and we can normalize that to get the surface normal at all points. Okay? Yan. So, unique na to. So, after that, once we get the surface normal, we perform this process, this line integral to convert the surface normals into a surface. Now, ang isang challenge dito is yung pag-compute ng line integral. Maraming paraan. Ang line integral kasi parang i-snake mo yung surface, i-snake mo yung path. Tapos as you integrate along that contour, okay, nakakalculate mo yung height. So, nagmamatter minsan kung ano yung direction mo ng pag-integrate. And maraming mga techniques na to do a line integral. Kaya nga ito, enumerate ko dito na meron na, you can either do this equation mano-mano, or you can check out these algorithms if you can find a code for them and then just use them to recover the 3D shape. Okay? And here are some more resources where you can get them. Malinaw ba? So sa totoong buhay, kung gagawin mo to, okay? Kukuha ka ng light source. Medyo medyo tricky to ha, kasi kailangan napakalayo ng light source, right? Nagagawa naman yan ng paraan. Minsan, merong light sources na collimated na mukha na siyang parallel rays. Kasi tatapat mo siya sa image, ay sa object, and make sure na i-estimate mo yung vector, yung surface, yung vector ng kanyang direction. Okay? Now, once you have an idea kung ano na yung B1, B2, B3, for each of these locations, capture an image. Then, that's it. Do this. Okay? Malinaw ba? May tanong ba? Wanna try this? Right. Upload natin yung photos.mat. Ano ba nakita yan last time? Photos.mat. Ooh. Okay. Nasa itong photos.mat guys, nasa ano niya na ha, Google Classroom niya na. Kita niyo ba yun? Okay. Okay, andito siya. Now there are ways of loading this. You can now you can, if it's a MATLAB file, it ends in .mat, no? You can just open it from using load, yeah, from here using the function load. Yeah. So look. Okay. Wala lang. Let's have a look now. How it looks. As you can see, here in this workspace, you see I1, I2, I3, I4. And I can display this. I'll show you a trick, guys, how to display this all at once. Have you ever tried subplot? So subplot, you first give the dimension of how you're gonna place it, and the last number is the place. So pag sinabi kong subplot 1, that's the upper left corner. Then I can go ahead and show I1. Then subplot, same dimension. Then the second placeholder, show, and so on and so forth. 2, 3. Lastly, there. Now let's run this section again. Ding. Ba't ang dilim? Uy. Ay, joke. Double siya. Dapat pala image AC yung ginawa ko. Siya na. But okay lang. Pwede ko rin i-uint8 ito. Wait lang double check ko lang kung ano yung values nito. Baka mamaya Okay. Meron ba siyang... okay. So it's a number between 0 and so dapat image SC na lang. Sorry. Sorry to disappoint you guys. Let's just replace all of these with this para limitaw. Well, image SC automatically scales the intensity. So kahit double kaya niyang i-display. So kung hindi image ang matrix, okay lang. Use image SC instead. Kahit lagpas pa ng 255 yan, or it's a number between 0 and 0.5, kaya niyang i-rescale. Okay. So how do these look? It looks like, there you go. So false color lang to, but these are hemispheres with a pattern, cross pattern on them. I don't know if it's obvious, but you can see here that yung brightness kinds of looks like it's off-center. Do you notice na ito banda dito? So you can imagine that the light source is like this one, the light source might be somewhere here. Or as this one, parang yung light source ay medyo parang dito. This one, parang yung light source parang dito sa baba. And this one, I don't know, parang medyo sa gitna. Diba? Nakikita niyo yun from this shading here. Okay? Ito ba natin? What would happen if I put this color map? Para lang, kasi medyo distracting yung just have a look. We do this. Section. Yon, that's better. So that's how it looks. if in grayscale. Yung kanina false color. Alright? Kanina nung false color map, medyo mas obvious na iba-iba yung location ng light source. So ngayon, medyo hindi na. But you can, at this, medyo nakikita nyo na hemisphere siya. Okay. Now that we've loaded the pictures, now let's make another section. And this time, we get V, no? Let's write the V. So for here, we need to calculate, let's right away calculate G muna, okay? So for that, we already have the I1. Now let's get the V's. Okay. So since I'm lazy, I'll go to the classwork part and just copy this again. Copy you. Okay, wait. V equals. No, wait, not that. Now I want to make a matrix of V. So how do I do that? Ganito yan. May comment out ko lang yan. Iisa lang yung V natin, ano? It's gonna look like. Ano, sige, okay na to. Okay. Palitan lang natin to guys ng square bracket. So yung nag-simulate nitong image, siyempre siya na yung nag-indicate ng light source. You can render these artificial images with a given light source location kasi. So dito. Now remember, sabi doon sa notes natin, lapit na. G is this and I is supposed to be, okay, so medyo challenging to, no, to think. I is a square matrix, right? For each point I, merong xy. There's a unique V, and there would be G. Okay, so let me show you a trick. We first concatenate I. Wait, let's first make a V, shall we? So V should be an n by 3 matrix. And to do so, we can write that as V1. So the semicolon moves it to the next row. Okay? V3, V4. Okay. Okay. All right. Pag tama yung ginawa natin, this should look like a 4 by 3 matrix. Let's just run this section, shall we? Ito lang. And let's visit this. Tama, 4 by 3. So we're sure walang error yan. Okay. Now let's, I think I put a section break just to be on the safe side. Okay. Now the trick here is we concatenate the image I. No? What do I mean by that? We form it into vector. The matrix, we will collapse it into a vector. So, di ba, kunyari, itong vector. Ito, pag uugnayin natin, gagawin lang natin siyang isang mahabang line of numbers. And the way to do it is by putting a colon. Like for example, I test. Ito ha, tingnan nyo dito sa command window. If I go I1 of colon, pag ginanyan ko, tingnan nyo yung sa workspace. Magiging isang vector na mahaba na lang to. Just like this. Yan. That's concatenation. And we need an eye in the shape of apat yung images, ano? Apat yung images. Tapos, dun sa equation, i-multiply natin siya sa vector na to. Ano yung itsura ng vector na to? Una muna, V transpose is 3 by 4 multiplied by 4 by 3. So, magiging 3 by 3 to. Tapos magiging inverse. Gayun pa man, 3 by 3 pa rin ito. Ito naman, i-multiply mo sa transpose ng V, which is 4 by 3, so magiging 3 by 4. Okay. Alright. So, all in all, this guy here is an image, or rather is a vector, which is 3 by 4. Okay? This tells us that for a successful matrix operation, I should be 4. No, tama ba? 4 rows and the number of columns should be equal to the total number of pixels, which means our I would be equal to this vector. Now, if we concatenate I this way, one of the images this way, is going to be column vector. But what we want is we want it to be a comma row vector kasi kailangan yung mga eyes, nakahiga sila lahat. I. And so, this is what we do. I1 of colon, then we concatenate. We transpose. That's how we transpose. Tama ba? Check natin kung gagana yan. Dito, I test. Tapos lalagyan ko ng caret, ng ano dyan. Dapat transpose na to. So, makikita nyo, 1 by 16,384. Tama. Okay. And then we move on to the next row by doing this. I2 of colon. We go on and on. I3 of colon. Yeah. Lastly, I4 colon. Iihi ako, guys. Excuse me muna. Okay. Alright. Teka. On V concatenate I. Okay. Run lang natin tong section natin. Dapat 4 by total number of pixel tong I. Run natin tong section. Yun siya. Pwede. Okay. Pwede na tayong mag-section break. Bawli yun. Sabi doon, G is B transpose times B inverse tas B transpose times I. Tall order. Sana mag-work. Sana walang error. There goes G. So the first is we transpose B and we multiply. So walang dot, guys, kasi matrix multiplication. So in MATLAB, matrix multiplication doesn't have a dot. Okay? You do a dot multiply if you want element per element multiplication. we need to inverse this. And I think the inverse goes like this. Teka, wait lang ha. Double check. Meron nga ba? Well, kailangan natin ng inverse ng matrix. Ito nga ba yun? Okay. Looks like it. Ano next? Okay, isa-isahin muna natin kasi I want to make sure na hindi ito mag-fail. Okay. The next is okay. After that, i-multiply natin uli siya sa transpose niya. So, gawin muna natin itong intermediate na ano na to. Let's give it a name. Okay? And then, after that, i-multiply natin again sa transpose niya. Okay? So, kukunin muna to. Will it work? Try muna natin. Dapat, ano sabi natin, this is 3 by 3 multiplied by 3 by 4. Therefore, the result should be 3 by 4 matrix. Okay? Let's run this section. Looks like it. And so now, we can calculate G. G is equal to this V inverse times our I. Okay. Oh! Okay. And then, that should be it. Let's run this again, see if there's no problem. Did you mean? Ay! Oo naman. Saan galing yung X na yan? Sorry na, excited. Okay, ulit. Ayun. And now we have G. And what this means is, nakalculate na natin, kung ni-normalize natin to by its length, then actually this is already the normal vector. Okay? The XYZ component. Now let's normalize that. Okay. Step by step. Okay. Ano nga ba? Dapat may length to eh. Well, meron bang length ng vector? Given na vector, pwede bang may length siya? Ooh, length of vector X. Ay, hindi. Hindi siya yung ano. Joke naman to, hindi. It is equivalent to. Okay. Ano ba yung length ng vector? Di ba square root of G dot G? Okay. So try lang natin. Length G is equal to G transpose. Wait, ano ba yung G? O, tama. G multiplied by G transpose. Tapos, diba ang dot product ganito. Tapos, kailangan nating i-square root. Diba? Nagigets niyo ba itong step na to? This is equal to the length. Alam ko lang natin kung mag-work. Sana mag-work. Ganap. G length. Girl, bakit ka imaginary? Hoy, te, ba't ka imaginary? Ba't naging complex ang ganap? Bakit kaya? Takot naman ako sa'yo. Ba't complex yan? Tingnan mo guys, oh. Ayoko niyan. Wait. Inspection nga natin itong J-length values na to. Wait lang. Bakit tatatlo lang sila? Ba't 3 by 3 lang? I'm expecting this is... Okay. Mali. Diyan na. Mali. What we expect... So, mali to. Dito. Una muna, complex siya. Pangalawa, hindi ito yung in-expect ko. Mali. Well, ang G length of, say for example, G of colon 1. So, lahat ng G, X, Y, Z, or 1, 2, 3, ang first element, okay, multiplied by itself. Ay, pero transpose. Sabay square root. This is a single number. Dapat. Okay. Natin to. Ate, bakit ka? No, bakit kanya? Ba't 3 by 3? Mali.
Sa transpose po ba multiply or sa inverse?
Ha? Ano yan? Ha?
Transpose, square root of G times transpose. Dapat or inverse? Times inverse.
I'm sorry, what do you mean? Ha?
Kasi baka naging divide dahil na-multiply siya sa transpose. Or hindi po ba pwedeng gamitin yung function ng norm for the
Ano yun? Ano yun? Tama? Teka, may,
na function?
well, may electric fan ba sa gilid mo? Kasi
Ay,
parang
sorry.
ganun eh. Hindi ko maintindihan yung sinasabi mo. Ano ulit, girl? Ano na advice? Bakit 3 by 3 yung lumalabas? Ano yun po? Ano yun? Hello?
Chinachat ko na lang po pala yung sinabi ko kanina.
Ay, mali. Ito ata dapat. This times this. Okay. Mali ata yung pagka-transpose ko. Oo nga naman. Sige, promise. Hindi na to 3 by 3. Transaction. Single number na to. Yan. Okay. I got it. Mali ako. Dapat ganito. In the end, this should be 1 by 16,384 numbers. One length for each of the vector. Try natin kung mag-work. Hindi. Naging 16,384 pa rin. Oh no. Cannot be. Teka, may mali ako. Wait. Isip. Oo, tama. Magsi-16,384 nga. Hindi. Dapat. Okay. Ito na lang. Teka, ano nga? Teka ha. Dapat 1 by 16,384 yun lalabas. Paano natin mapapalabas yan? That with itself, dotted with itself, wait lang ha. Okay, parang pare-pareho na to eh. Wait lang, tingnan natin yung itsura nito. Again, ano uli Adi yung yung question, yung suggestion mo? Teka, there must be an easier way of doing this.
Parang may function po ata na nag-normalize agad. Either norm, parang norm po. Or, di ba lang, kina-calculate niya ata yung magnitude ng vector.
Gets ka na. So parang ganito. Ito, norm.
Yes.
Okay, let's look for norm. Okay, there you go. Okay, thank you. All right. Okay. So dapat G over element per element divide by norm G. Teka, tingnan muna natin. Ano yung magiging sige, i-test muna natin, G-test. Dapat ba, ang tanong ko kasi is, dapat itong norm G, dapat 1 by 16,384 siya. Otherwise, ita-transpose muna natin siya. G-test. Ha? At isa lang siya. No, bakit 1? Girl, bakit isang number lang to? No way. Transpose mo naman. Anong lalabas sa kanya? Isang number pa din. That's not right. Teka. Uli natin yung normalize a bit. Normalize? Oh, meron pa palang normalize na ano. Ano ba to? C-score. Hindi naman to Euclidean. Kailangan natin yung Euclidean. Mag-gets to. Teka, ulit. Euclidean norm. Okay. Try natin normalize norm. Okay, sige. Kunyari yung vector natin B is 3, 4. Okay? Ang length nito ay 5. So parang dapat ang lalabas ay 3/5, which is 0.6, and 4/5. Ay, joke. Ano to? 4/5. Tama ba? 0.8. So, dapat, test muna natin, normalize the norm na natin. Tama. Correct. Sige, okay na ako. Thank you, Adi. We learned something new today. Sige. Normalize G. Ay, wait lang. Try natin muna. Test muna natin, ano? Hindi ko alam eh. Pwede naman natin mag-test dito agad. D norm equals normalize G. Pero paano niya malalaman kung anong dimension? It's along the first dimension. And let's choose norm. Kasi otherwise, baka mag-normalize siya dun sa 16,384. Okay? Okay, let's see. Kung tama to, it should give us just 1 by 16,384. Ay, mali. B norm niya is 3 by 16,384 pa rin. Maka dapat along dimension 2. Wait lang ha. Tignan natin. Ano yung B norm? Aray, bakit ganyan? Hindi naman. So, medyo dapat 1 by ano eh. Baka may mali tayo dun sa syntax. Aralin ang syntax. So, basahin pa natin. Normalize a matrix. Okay. If A is a matrix, table or timetable, then normalize operates on each column of data separately. Baka dapat ganito na lang. Hindi na natin kailangang sabihin. Ang data niya ay nasa column. Okay. Baka nga enough na to. Huh? Ayaw. Ito, how about this? No. That's odd. If A is a matrix, normalize operates on each column of data separately. Ayun na nga. Kanina tama na yun eh. Ay, hindi. Oh, gets ko na. Okay. Tama. Okay, gets ko na. Okay na to. So, ibig sabihin, pag ginawa natin ganito, normalized na to. Kasi vector naman yan. Siya, hindi na natin i-divide. Okay? Dapat 3 by, yeah, tama. So, double check natin. Normalized na bali to. N equals normalize G, and we will use the Euclidean norm. Okay. Just to be on the safe side, let's do it again for B. Pero parang gagawin natin is paulit-ulit lang yung B. Like B is equal to ganito. Pero the data is per column. So X is the first row, Y is the second row. So kung kunyari gusto natin ng 3 points, ganito yung napare-pareho lang yung value, ganito yung itsura nito. Okay? So X value, Y value, 1 data, 1 data, 1 data. So pag bininorm natin siya as is, dapat 0.6, 0.8. Ay, joke. Dapat. Yes. So satisfying. And therefore, kung ginawa natin dito and G happens to be the same form, well, pag nakuha na natin to, N would be this. Yes, that's it. Thank you. Okay. Now comes, how do we display this? Hindi pa to. Actually, the next is, we just have surface normals. Section break. Want to check how N looks like? N looks like unit vectors. Okay, let's look at that. Nanay ko po, not a number. Bakit? Problema tayo dyan. Teka ha. We have a problem here. I think yung inverse nito kakaproblema. Okay, wait. Ayun, at least meron ng numbers, ano? So dapat ang length nito equals 1 pag pinanon mo. So there are areas which are not a number. We just have to manage those. Also, this is not yet a square. However, kailangan nating ma-escape yung mga not a number points mamaya. Okay? Ngayon, yung last na lang is the line integral. Okay. Sabi dyan, fx, kailangan ma-form natin to. Itong minus nx over nc kasi i-integrate natin yan. So, ang line integral, summation lang yan actually. So, first, ifo-form natin to. And then, we will define a contour. And we will go from 0 to that point along the x. And then u to be that point, y. Parang cumulative sum, ano guys? So, ang problema na lang, paano yung contour natin? Paano natin iti-trace, no? Medyo challenging to. Okay, so one way of doing this is, gawin muna natin tong first part lahat. So, x, all along the x, mag-sum tayo from 0 to u, cumulative sum. Parang cumulative sum to, no? Okay? Ito naman, isa-sum din naman natin along the y. So, para ka tayo nag-sum along the y. After that, i-add natin silang dalawa and see what happens. Okay? So, what I mean is, try natin. Lapit na. Okay, sara muna natin ito, please. Okay, line integral. Mga tol, mga aso ko. Baka may nagpapapirma. Alam na this project later, may mga papeles na kailangan pirmahan. Wait lang guys ha. Checkin ko lang. Message pa. Wala naman. Okay, wala. Okay. So, what do you mean by this? So, gawin muna natin yung df dx. Dx, tama, is equal to minus nx over nz. So, nx is the first row in this 1, 2, 3. So, yung sabihin na, gagawin natin is in first and all elements there, no? They're corresponding to all points. By the way, since i-reshape muna natin siya into area, the same area, no? Kailangan natin siyang i-reshape. So, sasabihin natin, reshape back into an image matrix. Kasi mag-integrate na tayo along x and y, kaya importante ito na bago natin gawin itong part na ito, reshape muna natin. Alam ko may reshape dito. You know. So, reshape, kailangan lang natin i-define yung shape. Okay. So, this is, let me show you a trick. In shape in. Tapos, gagamitin mo is yung size nung isang image as a reference for the dimension. Okay? I-section break natin. Ayoko na ulitin to. Okay? Okay. In the end, dapat magmumukha siyang 128 by 128. Okay? Try natin. Silipin to. Wait. Teka, nakaban ako din na. Gawin natin for each of the elements. Sige, nx. 1, all rows. Ito na muna. Okay. All columns. Transaction. Ito yung nx kasi first row. Oha guys, 128 by 128 na. So, repeat performance lang. Control C, Control V, at isa pa please, Control. Yan. Meron tayong X, Y, and Z. And, you know, we just put and 3. Yun. Tapos, transaction. Yan. Nakahiwalay-hiwalay na yung XYZ component natin in image form. And so, ngayon, ito na lang. NX divide by element NZ. Yun. Tapos, df dz is equal to, nakakasabi niya? Minus ny nz. Ay pa ba ng time natin, guys? Ano yan? Meron pa. Minus ny, element per element in. Ngayon, may kaba ako na baka hindi mag-work kasi meron mga ano ba itong not a number. Probably 0/0, which is y. No? But let's see if it nuns as well. Let's just skip that. Tingnan lang natin. One section. Hindi naman nag-error. So baka may effect. So baka okay lang. Tingnan natin. Tingnan natin. Baka may none pa rin to. Unfortunately, may mga nuns pa rin, no? And tingin ko, based on the shape of it, these may be itong parts na to, no? Na black. Totally black. Yan. Not a number siya dyan. I think this is already part of the circle. That's why. Okay. Gayun pa man, let's push on. At least MATLAB recognizes the not a numbers and yet pushes on. Okay, we now have the df dx. The thing is, we have to sum along the x. So the first term is like a cumulative sum. So x cumulative sum is equal to cumulative sum of df dx. Okay. The second term is parang cumulative sum naman. Teka. Along the y direction. Guys, ganito yan, ano? So, suppose this is the matrix. We're first taking cumulative sums this way, this way, this way, this way. Tapos, kukuha tayo ng sum along this direction. Kasi i-add natin sila. Hindi ko alam, so we have to indicate when you do a cumulative sum, because you have a 2D matrix, you have to indicate where it is summing at. Is it in this direction or in this direction? So let's check. There is a cumulative sum. Okay. So if we indicate the dimension, it returns the cumulative sum of the elements along the dimension. Okay, so for example, cumulative sum A2 returns the cumulative sum of each row. Okay, balik tayo dun sa B natin, ano? Alright. So, kung sum B1, first dimension, ibig sabihin ba ganyan? Ganyan? Tingnan natin. So, dapat, kung ganon, magiging matrix may 3, 6, 9, and 4, 8, 12. Tingnan natin. Ito pa lang, ginawa niya, sinam niya pa ganito. Okay? Ito yung pababa. So, ibig sabihin, kung gusto natin pa side view, pa ganito. Yung Okay, hindi ko alam kung ano yung uunahin, but well, hindi ko alam. Flip natin to. So, yung isa, dapat along X. Dapat ito, 2. Yung isa naman, dapat along Y. So, dapat DC talaga, hindi DY. Ano nakasulat dun sa notes ko? Girl, DY. DC yan. Confuse yung mga magbabasa niyan. DY. Yan. Dapat ito, 1. Ay! Tapos, yung F is equal to, ito na. Sasam lang natin yan. Pareho naman sila ng shape eh. Hindi ko alam. Okay, so maraming points of failure dito. Ito, okay na. No? Hindi natin alam kung magsasummation siya kung not a number. But, sige, mag-ano na tayo. Section break. Tapos lagay tayo. Get line integral. Kinakabahan ako. Click. Ay, joke. Bakit? Hindi ba ito na-calculate kanina? TC, ay, sorry, TC. Malay nakasulat dito. Ulitin lang ito. Ting. Okay, ito naman. Ito na! Runs. Ito na. Run section. Aba, walang arrow. Itsura ito. Ano natin yung itsura na? May mga not a number pa rin. Pero ito na yun, guys. Eh. Dapat ito na yun. So, tingnan natin bandal ng gitna kung ano lumalabas. Okay. Maliban dun sa may mga not a number, may mga lumalabas na values dito. Hindi ko lang alam kung it makes sense. Okay. Well, here goes nothing. Tignan natin kung madi-display at all. Oh! Baliktad lang nga. Okay? Doesn't that look like a hemisphere na baliktad? Subtract kaya natin. Gawin kaya natin ganito para bumaliktad. Ayos ba, guys? This looks like a nice looking sphere, doesn't it? Ayos ba? I'm happy. Nakaban ako kanina. Pero it worked out fine. Ay, teka, ano ba? Rotate ka, girl. Gusto kitang pa-rotatein. Show yourself. Project. Work it. Tayo mag-rotate. Rotate. Sabi yan. Rotate. Rotate. Did you get the same?
Yes, ma'am. Yes, ma'am.
That's it. We're done with activity 8.
Yeah.
Okay. Hindi ko ma-rotate. Kaya niyo bang i-rotate?
Yeah, ma'am.
It's working naman for me. Sa akin, bakit ayaw? Baka kasi offline. Online. Does it look like, ano tayo? Pa-share naman yun sa inyo. Kasi hindi ko ma-rotate eh. Stop share ako. Nakiikot-ikot nga. Pa-share naman sino mag-share. Adi, Bea, ikaw, kaya mo?
Yeah.
Adi, ikaw, na-try mo sa PC mo while watching this? Okay. Yeah, that looks like it. Looks like a sphere indeed. Okay, all right. Ayos ba, guys? Thank you. Adi, how about you? Okay ba? Lumabas mo yun sa'yo? Are you able to share your screen or wala ka or kahit i-share screen mo using your mobile? point it on your monitor. Pwede yan, di ba? Ate. Hello, Adi? You're muted.
Yes.
So, what if sa totoong buhay gagawin nyo to? Again ha, ang critical dito is the determination of this bee. Kasi madali lang naman kumuha ng image, di ba? Kung dyan may lamp ka, and itong rays ng galing sa lamp mo is parallel, sure ka. Move mo lang yung lamp. Kada move naman ng lamp, mag-i-elicit ng shadow. Alam nyo ba guys, ito yung paraan kung bakit Google Maps can recreate the terrain. Kasi sunlight ang tumatama sa ano. Di ba may mga nakita niyo sa Google Maps? There's a choice there where you can see the terrain and you can see the 3D of the mountains. No? Kasi sunlight is so far away, it's considered a parallel source. And when the sun or the earth rotates, parang imbis na gumalaw yung araw, gumalaw yung earth, parang anyway, motion is relative. Relative to the earth, gumalaw yung moon, yung sun. And pag nag-move na yung sun, apparently, from the earth's point of view, mag-iiba yung shadows ng mga bundok. And since the satellite overhead takes pictures of the scene different times of the day, they can be reconstructed. So may mountain, tapos nakunan siya ng picture at different times of the day. So at different times of the day, may iba't iba siyang shadow. Tapos may estimate mo based on the date and the time kung nasaan yung location ng sun. Therefore, marireconstruct yung terrain 3D ng mountains. That's how it's done. And the same is done also on Mars. Okay, makukuha rin. There are several ways to get 3D. Another way they're doing it in Mars and in self-driving cars is by, it's called shape from motion. Shape from motion. So long as you have a single camera and it's moving, it's like you have several views of the scene. And as long as you have several views of the scene, you can do stereometry. Yon. Ayos ba? Happy?
Yes, ma'am. Yes, ma'am.
Okay, that's it. We're done with activity 8. All right. Adi, success naman sa'yo, no? No need to show. No need to labor on it. Basta napagana mo. Enough na assurance na yan. Okay? Okay, we're done. 9:59, exactly on time. So, that's it. Thanks, guys.
Thank you, ma'am.
See you next time. We're the last meeting. We're gonna last 3D. Yeah, so please don't be absent. I'll still meet you. Ay, wait. Wala, next week. Wala na tayong meeting next week. Wala nang Thursday. Kailan ba yung end of classes? Meron pa tayong isang lesson.
Tuesdays.
Tuesdays. Ano ba yung lab natin? Lab day natin dapat. Kumirit ng lab day.
Friday, ma'am. Morning.
8:30. Are you game? If I see you on Friday morning, so that we can do the next activity.
Tomorrow.
Oh.
Okay.
Last activity is the last 3D technique, and it is called phase shift profilometry. All right. Once again, I'll just give you some sample data, and then let's work on it together. Get you what?
Okay, ma'am.
8:30 to 10. Ako, stress. Tapos 10 to 11:30 may klase ako. Tapos 1 to 4 may meeting ako. Bye! Kaya yan. Okay.
Thank you, ma'am.
Bye. See you tomorrow. Bye.